Completing the square is a process to put a quadratic equation into a form in which we can apply the square root property. Note that we currently cannot apply the square root property to this equation because we do not have some expression squared equal to a real number. The best way we can show the process of completing the square is by example. So here we have the simplified case where the coefficient in front of the x squared is a 1. So the next thing we do is get the constant on the right side of the equation by subtracting 11 from both sides. This gives us x squared plus 12x equals negative 11. We now force the left side to be a perfect square, which will allow us to use the square root property. To do this, you take half of the coefficient on the x term, you square it, and you add it to both sides. So, if we take the coefficient on the x term is 12, so if we take half of that, that's 6, and then we square 6 to get 36, we want to add 36 to both sides of this equation. So on the left side we get x squared plus 12x plus 36, and on the right we get negative 11 plus 36, which is 25. Now the whole reason that we take half the coefficient on the x term and square it is because we have now forced the left side of this equation to be a perfect square. That is, we can factor it as a perfect square trinomial. So this factors as x plus 6 squared, right? If we FOIL this back out, we're going to get our x squared plus 6x plus 6x plus 36, which becomes this. And on the right we have 25. Now we have put this in the form in which we can apply the square root property. Namely, x plus 6 is equal to the square root of 25, or x plus 6 is equal to negative square root of 25. The square root of 25 is 5, so if we subtract 6, we get x equals negative 1. Over here, the square root of 25 is 5 and we have a negative in front of it, so that gives us negative 5. If we then subtract 6 from both sides of this equation, we get x equals negative 11.